Hello guys, welcome back to learning microcontrollers. In this video, I'm going to show you how you can make a PIC16F877A based 4-lane traffic signal controller. This is a tutorial. In this tutorial, I will demonstrate the output using the Proteus simulation. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This is our 4 lanes. Let's suppose these top 3 LED signals are for the lane 1, bottom are for the lane 2, right are on the lane of the lane 3, and suppose the left one is for the lane 4. Now guys, suppose this is connected with the PIC. I will show you the circuitry on the Proteus simulation software, so you can easily understand this, how to implement this. So guys, what is going to happen is that will be the final result when I will run this PIC. After doing the programming and making the circuit, this is what is going to happen. Then initially lane 1 will be green while the rest of the 3 lanes will be red. Then lane 1 and 2 will go yellow, lane 1 will turn red, and then after that lane 2 will turn green. Now guys, lane 2 and 3 will turn yellow, lane 2 will go red, and after that lane 3 will turn green. Again, now lane 3 and lane 4 will go yellow, while rest of the 2 lanes are at red. Lane 3 turns red as well, while the lane 4 after that turns green. In this way guys, then it will repeat the loop. It will go back to lane 1, 2, 3, 4, and we can set the times as we like 30 seconds for green light or 40 seconds depending upon our requirement. So guys, let's get to the Proteus to show you how to make the circuitry. So turn on your Proteus. This is what you get on the Proteus if you turn it on. Now first of all, I turn on the magnifier so I can zoom it in so you can see better. So this is the let me zoom it in. Go to the left, click on file, a new project. Already selected, I click on ISIS here. This leads you to this window. Before doing anything else, go to this devices. Here you have this P, click on it and fill your bucket with the components you need. Write down PIC16F877A. This is a PIC microcontroller. You place it on the screen. Now go back again. Now write down TIP122. I'm gonna use this transistor. I will tell you why. You have this in the bucket. Now we need LEDs. Click on LED. Now click here and see here. We need the LEDs green. Okay, we need the green. We have it in the bucket now. Now go back again. Again write LED. We need yellow and red as well. Again. Go down. Okay, this is green. We already have. Now this is red. We have the red as well. Now go back. We also need a yellow LED. Now again, look here. This is the yellow LED. We have the yellow as well now. Now we need the resistor. Write down RES. You get the resistor. We have the resistors as well. Now guys, this is our microcontroller. As you can see, this is a PIC16F877A microcontroller. Now first of all, I need to make a segment here. For that purpose, I choose red LED on the top. I place red LED here like this. Now guys, the thing is that signal you see on the roads is made up of 5 mm crystal LEDs. They are connected in a grid. You cannot power up many LEDs using PIC16F877A single pin. So for that purpose, we will need a TIP122 transistor. This is the transistor you can use. But before that, let's place the LEDs. For the demonstration purpose, I will use 6 LEDs. 1, 2, 3, 4, 5, 6. Usually you can use 24, 30, 60 depending upon how much brightness you need. So I'm using 6 LEDs only demonstrate to you. If you want to add more LEDs, you simply add them in the parallel, and on the hardware you can implement this in any design. Never connect an LED directly. Always use a resistor to limit the current like this. 10 kilo ohm is a very huge value. It will lower down the brightness to a great extent. Make it 220 ohm, 0.22. Now that's great. Now what you do, you copy it. For each LED, there must be only one resistor. Combined, some people use combined resistor, but I don't recommend that. That lowers down the brightness and also causes more current to flow, which can cause a single LED, that is the first one to receive, burn. Like this. Place them all 6 resistors for 6 LEDs. Now you connect each LED with one resistor. Remember, these are all 6 LEDs. These all are red. They are only for the lane 1 red LED. By red LED, I mean a segment of LEDs. If you open that signal box that you see on the street, you look, you will find that there are many LEDs connected in parallel like this. So I'm connecting 6. You can connect more, just add them in the parallel. Further, you can add as many as you want. So guys, in this way, you connect your LEDs. Now on the top as well, you common these resistors like this. This is red segment of lane 1 signal. We will make the lane 1 signal, but then we will copy paste it. Now it is complete. Now guys, this is our lane 1 signal. You need to power it up. You have to power up the signal using a separate power supply. You can use a power supply up to like 400 watt. That will be great. 5 volt 400 watt if you are using these 5 crystal LEDs. It will be able to power up all the LED segments even if you use 24 LEDs in a pattern. But remember that for PIC you have to use a separate power supply. You add another 5 volt small supply that must be like 10 watt or 15 watt, 24 watt is more than enough. You simply connect it with the PIC with separate power supply. Ground of both the power supplies must be common, but power pin of the smaller supply, 10 watt supply, will go to the PIC, and for the 400 watt supply will go to the LED. That is the power pin. Now guys, this is our first segment of first lane, that is red LED of the lane 1. Now we need a green LED. So you select the green from the bucket. Oh sorry, yellow is in the center. We use a yellow. Add 6 yellow LEDs like this. 1, 2, 3. Just make it as neat as possible. Copy to clipboard, then paste it. Now these are 6 LEDs. 6 yellow LEDs. Again do the same. You will need 6 resistors. Simply copy paste them from here. So there we go, our 6 resistor for the yellow LEDs as well. Move it a bit right so it comes under it. Try to make it as neat as possible. I am trying to do it. Okay. This is connect one resistor with each LED like this. That is with the anode of the each LED, positive pin of the each LED. Remember that this bar is always the cathode side. You connect it to the ground, or in case of a transistor to the emitter side, and collector side in NPN transistor must go to this positive side of the LED. So in short, the longer pin that you see on the 5 LED is the anode, and the shorter is the cathode, negative pin. Anode is positive and cathode is negative. So guys, in this way, all 6 LEDs of lane 1 yellow segment is connected. You can connect more, as told you earlier, as many as you want, following the same sequence. If you fall short on current, you can change the transistor. Let me show you how. Okay, this is our second segment. Now remember, power supply is same for both the segments. So you connect it like this to the same power unit. That is 400 watt will be able to power up all 4 signals like this. Now guys, we need our red, yellow and green is left. This is green. You select green LEDs. 6 green LEDs will fine for the demonstration purpose. 3, 4, 5 and 6. Here we go. 6 green LEDs. Now I common their bottoms, that is cathode side. Cathode sides of all 6 LEDs are common because they all have to run with a single transistor, a single pin of the microcontroller, because they all are acting as a one segment. Now you add resistor again. You simply copy paste it. Copy it from here. Paste it above it like this. One resistor for each LED like this. This will limit the current. I am using 220 ohm resistor, and 220 is very fine to maintain the brightness of a 5 crystal LED. If you use some different type of LED, you can use a different type of resistors depending upon the brightness. Okay, now connect the top other end of the resistors will get common like this. Now this is red of lane 1 signal. This complete represents a segment of yellow. This complete represents the green segment of lane 1 of the traffic signal. Now again, as done with the previous, they have common 400 watt supply. Now we place our transistor. This is a TIP122 transistor. This transistor has a capability of holding up to 6 ampere of current. Because this was to need a lot of current to operate, we cannot use the pin of the PIC directly on this. You can connect this directly, but it will not be able to power up all 6 LEDs, or they must be more like 24 to 30 LEDs in one segment of one traffic signal. Because of this, we need higher current. We use this transistor. This PIC will give signal to this transistor, and this transistor will be able to drive this load with a signal provided. A very small signal is needed for the transistor to drive the load. Once the load has been driven, then pin has nothing to do with it. So guys, in this way you will run this load. If you have more current than 6 ampere, you are using different type of LEDs, then what you do is that you simply change this transistor. Base of every transistor is always the base, collector is collector, emitter is emitter. So you have to follow exactly the same pin configuration on the data sheet. B, C and E, it might be C, B, E, E, B, C, but there must be 3 base, collector and emitter on every transistor. And if you fall short on load, you can change the power supply from 400 watt to 1000 watt depending upon your requirement. While the schematic and design of the circuit will remain exactly the same, even the main thing, that is the programming of the PIC16F877A, will also remain the same. Now let's connect our TIP122 transistors. That is one for this segment, one for this segment, and one for this segment. That is for the red, that is for the yellow, and that is for the green. Now I select the pins. Let me move the PIC a bit away so we can go a bit neat, because we have to connect other segments as well. So red pin of the lane 1 signal I connected to the B0. Remember, this B0 is the red. We will use this in the programming. When I give signal 1 to this pin, it will drive the whole load. But we are making a mistake here. Do not connect this directly. Use a resistor. 10 kilo ohm resistor is more than enough for each base pin of the transistor like this. Now you connect your resistors pin number B0 to one end of the resistor. From the other end, it will go to the base of the transistor. In this way it is connected. I am using pin number B0. You can use any available digital input output pin for this purpose. Now for the yellow signal, I am using B1, and other end of the resistor will go to the base pin of the transistor. Now for the red signal of lane 1, I am using B2. That will go to the one end of the 10K resistor, and other end will go to the base of the transistor. Now guys, this pin, that is the emitter, is the common ground. You common them on all 3 transistors like this. And in the real hardware, this will go to the common ground of the circuit where all the power and PIC grounds are connected like this. And in case of this simulation, you go to the left. In the terminals, you have this ground. You place it here or anywhere you prefer, and you connect it to the common ground like this. And the other pin, that is the collector pin, will go to the cathode side of the LEDs like this. For each you do this. Of the second transistor will go to the cathode side of the yellow LED, and for the third transistor it will go to the cathode side of the green LEDs like this. Now this is our segment. This is the red LED segment. You can connect as many LEDs as you want, and if you want to increase the current, you change the transistor or the power unit as required. And this is the yellow segment, and this is our third segment. I write on it that it is lane 1, signal 1. I write it like this, lane 1. Let me drag it here. It's lane 1. Let's save the project. Traffic signal learning microcontroller 2. Okay. Now for the lane 2, for lane 1 we have B0 pin for the red, B1 pin for the yellow, and B2 pin for the green. Remember, these pins if you make them, if you are using some other microcontroller, if you have any other digital input output pin, only difference that you have to do in the programming, you have to initialize the different pins. Rest will remain exactly the same. So this is very important. Now for the second lane, what we do is that we simply copy this. We don't need the power. Power will remain same for the whole circuit. You copy this, paste it wherever you prefer. I place it right below this. And now for the third lane, I place it here. For the fourth lane, I place it here like this. Now this is for the fourth lane. These are our all lanes. Red, green, yellow lane 1, red, red, yellow, green lane 1, red, yellow, green lane 2, red, yellow, green lane 3, red, yellow, green lane 4. Rename this to 2. This is our lane 2. This is our lane 3. And this is our lane 4. Like this. Lane 1, 2, 3, 4. Now for the lane 2, only the thing that we have to further connect after copy pasting it are the number 1 power supplies, that we are using exactly the same power units. So you connect it from here. Let me zoom out and use the built-in. You add a point here to make a line. Connect to the same like this. This is only one I told the power unit that you will need for the whole segment. So I comment this with this unit. This is the unit we are using here. Also do this for the lane 3 and 4. There we go. That is for the lane 3. And now for the lane 4, since it is connected, you only need to extend the wire from here because it is connected from above. Now you connect it to the lane 4 as well, like this. Now this is connected. We have grounds of each lane and we have the power for each lane. All we need is to connect the control wires to our required pin. Now for the lane 2, I connect the red pin, that is red wire. This will be the signal for the red of lane 2 to the pin number B3 of port B. Now for the yellow of red, lane 2. For the yellow of lane 2, I select the pin B4 of port B. This is yellow. And for the green of lane 2, I select the pin B5 of port B. This is pin number B5 of port B. See, during programming, this will help me. It is better you write them down as well on the paper, whatever pins you select, because they are very critical during the programming. Now for the lane 3, I use C0, pin number C0 for the red of lane 3. Try to be as neat as possible. I go up from above, I can take it to the lane 3 red. Here you go. Now this is lane 3 red. Now for the yellow of lane 3, I use pin number C1. This is what I will use for the yellow of lane 3. Again, you go up. Try to be as neat as possible. This is yellow of lane 3 connected here. Okay. This is yellow of lane 3. This is red of lane 3, C0, C1. And red of lane 3, I select C3, pin number C2, C2 will be the red of lane 3. I connect it like this. Again, go up, try to be as neat as possible. Now again, this is the red of, this is the green of lane 3. I connect it here. So pin number C2 of port C is the green of lane 3. Now for the lane 4, I will use the port easily available, that is this port. So I connect green of lane 4 to the pin number D0 of port D. So I go here to the lane 4. Let me zoom out. Zoom in again. This is our lane 4. Pin number D0 is the red of lane 4. Now for the yellow of lane 4, I am going to use a D1. Again, you go down, go to the right, look for the transistor base pin of yellow to be connected to the lane 4. Okay, it is having problem going from here, so we go from the bottom, but try to be neat whatever side you select. Even in the simulation, try to be as neat as possible. No, this is not good. Okay, this is yellow of lane 4 that is connected to D1. Yellow of lane 4 is connected to D1. D0 is the red of lane 4 and green of lane 4 I connected to the pin number D2. Come from the bottom. Wherever you come from, remember to be very neat. So this is our last connection. So guys, in this way our hardware connections are completed. If there is any problem, we will see during programming. Now guys, let's get to our MikroC for PIC and start our programming. This is the MikroC for PIC. Go to the file, click on new project. I am using version 5.6.1. You can use the latest version, but remember in the latest version you have to be careful about the capital and small letters. Rest of the syntax is exactly the same. Write the name of the project, learning microcontrollers traffic 11. PIC16F877A is the microcontroller I am using. 20 MHz is the crystal I am using. Click on next, and finish. Now guys, as you can see in the Proteus demonstration, we are using 3 ports, that is B, C and D. I further commented that port B holds lane 1 and 2. Lane 2 at lane 1 R is equal to B0, Y is equal to yellow is equal to at B1 and red is equal to at B2, and for the lane 2 at port B, red is equal to B3, yellow is equal to B4 and green is equal to, this is green, sorry, not red, it is green, and green is equal to B5. So lane 1 B0, B1 and B2 are red, yellow, green. For lane 2 B3, B4 and B5 are red, yellow, green. Now port C holds lane 3 at C0, red is equal to C0, yellow is equal to C1 and green is equal to C2. Okay, now lane 4 is at port D. Port D holds lane 4 at R is equal to D0, Y is equal to D1 and G is equal to green is equal to D2. So guys, these are the pin configuration I am using. You can use the other configurations depending upon the availability of digital input output pins. If you want to use this program on other PIC microcontrollers, you can use it. Only the difference it will make is this: the pins you select, you must use the same pin in the programming. So guys, let's get started with the programming. First of all, we initialize the pins and ports we are using. Trace B is equal to 0 cross FF. Since I am not using anything else on the pins of port B, so I will initialize the whole port as output. Sorry, 0 cross 0 0. This means the whole port is output. If it was 1, it means input. You can use the buttons, but in this case it will be an output port. So port B is output port. Now give the initial state. Port B is equal to 0 cross 0 0. Initially all the pins of the port B must be at 0. that they all must be having exactly off state, that no LED should be initially turned on. If you remove this command, there is a possibility that LEDs might be at on state. So port B is initialized. Now we initialize the port C and D. Write down, this is port C now. Make it C. Make it C. Now port C is initialized. Similarly do for the port D. Okay, add D here. Now this is our port D. Now port D is also initialized as an output port. These delays are only for the initialization delay. It is better you use them to make it better on the hardware. In the simulation it will work, but without this it may cause trouble in the hardware. So now we write our forever loop. Forever loop is represented by while 1. It starts here and here. Now first of all, the first step is that only lane 1, as shown in the presentation, green LED must be on. Lane 1 green is on while 2, 3, 4 are off. So we do this, that is our first step. So lane 1 green LED is port B.F2 is a green LED of lane 1. It's on. So green lane 1 is on. Okay. Now port B.F2 as shown in the Proteus is our green of lane 1. It is initially on while rest of the 3 lanes, lane 2, 3 and 4 are off and red are on. If green is off, then red is on. So red LEDs of all 3 pins must be on. All 3 lanes must be on. So we do that. So B3, C0 and D0 must be on. B3 is the red of port lane 2. So port B.F3 is equals to 1. Red of lane 2 is on. Now copy this simply to make your life easy, or you can write it down depending upon your preference. Now C port F dot, C dot F0, that port C0 is on, that is red of lane 3 is on. And now again red of lane 3 D dot F0 is lane 4. Now see what is happening here is that green as shown in the presentation for the first step, port B.F2, that is lane 1 green is on. So if the green of one lane is on, then all 3 lanes must be at red. That is common sense. See, port B.F3, C0 and D0 are the red of other 3 lanes. So they are on. If green is on, then green of the others are off. Only red is on. We don't write off state because we had initial state off. See, they are initially all the pins are off. Only those are turning on which we are turning off. So we don't have to turn off the green. We only turn on the reds. Now guys, this is the first step. For 30 seconds, you can select the time as your preferences. For 30 seconds, it should remain in this state. That for the 30 seconds, this lane 1 is on. Lane 1 cars can move. Now, what happened is that as shown in the presentation, now yellow of lane 1 and 2 both will turn on. Yellow of lane 1 is port B.F1 is equals to, don't write the state, this is basically yellow of lane 1. See, turns on 1. Yellow of lane 1 turns on. Now, yellow of lane 2 will also turn on as shown in the presentation. Now, yellow of lane 2 is at D4 as shown in the Proteus simulation. It must turn on. Both are on. What should turn off? Green of lane 1, this pin must turn off now. After 30 seconds, it should go off. That is 0. Now, what should turn off as well? That is the red of lane 2, that is on. It should also go off. Make it off. It will turn off. 0. Now, for how long should it stay in this state? For as much time as you want, but yellow light is on for 3 seconds. For 3 seconds, both are on. Now I built the code. Before we continue, we test it. It is better to test the long codes after interval. We first test it. If there is any error, it do not works as designed, then we remove the errors first. So first of all, we click on PIC16F877A microcontroller, double click it, write down the crystal. We are using 20 megahertz. Go to this folder. Here you select where you have built the code. I had built it here. This is the one I am using. Okay, so I run the simulation and let's see, does it follow the programming we just wrote? Okay, this is lane 1, 2, 3. See, lane 3 is red, lane 4 is red. Lane 4 red, lane 3 is also red. Lane 1 is green and lane 2 is also red. This is perfect, and the time is just 3 seconds. It will change the state after 30 seconds. So guys, it's nearly 30 seconds. Let's see what happens. This is lane 1, this is lane 2. See, both LEDs are on. It means our code is working exactly as programmed. So we go back to the programming and continue. Now let's get back to the MikroC. See, both are on. Now what happened is that since lane 1 is going from green to red, it should go red first as shown in the presentation. Then the one going from red to green should go green. So what we do is that we have to make lane 1 go red. And what is the red of lane 1? B0. So we write port B dot F0 is equal to 1. That is, red of lane 1 turns on, while at the same time yellow of lane 1 turns off. Yellow of lane 1. This is the yellow of lane 1. This have to turn off. See, that is what happens. Now, for how long this should continue? For I make it 1000 seconds. It remains in this state. I make it 2 seconds. Sorry, 2 seconds. It should remain in this state. Now what happens next is that the other one, lane 2. Now yellow of lane 2 and green of lane 2 turns on. Now green of lane 2, what is the green of lane 2? That is B5, port B dot F5 turns on. And what is the yellow? That is B4, B dot F4. You can confirm it here. See, this turns on and this turns on after 2 seconds. And for how long it should remain in this state? For 30 seconds. Now for the 30 seconds, lane 2 will turn on. Cars can go from lane 2. We test this before we continue. So let's get back to our Proteus and see till here if our code is working as intended. So I click on run. Code is running. See, red. Lane 2 is red. Lane 4 is red. Lane 3 is red. Lane 1 is green as intended. See, you can see that it is working as required. Now time is simply 10 seconds. After 30 seconds, it will change at first stage. At this time, lane 1 is on. People can go from the lane 1, while rest of the 3 lanes are off as required. Now it is at 12 seconds. Let it go. So it is now at 28 seconds. Let's see, the change of state will occur now. This is lane 1. See, both have gone yellow. That's perfect. Now lane 1 is yellow, lane 2 is yellow. It's 3 seconds. See, lane 1 has turned red. That's excellent. That is what we just wanted. Now this have to turn green. Let's see, does it work? See, it is green now. This is lane 1 is red now. See guys, this is working exactly as intended. Now after 30 seconds, it will repeat the loop. This is for 2 lanes now. Now we add the other 2 lanes as well. See, this is working exactly as intended. So guys, let's stop the simulation and get back to the MikroC to build the code further. Now lane 2 is done. Now we have to get to the lane 3. Now after 30 seconds, what happened is that lane 2 green will both yellow of lane 2 and that is the yellow of lane 2 turns on, and yellow of lane 3. Yellow of lane 3 is at port C dot F0 equals to 1. Sorry, that's port C. dot f0 equals to 1 yellow of lane 3, like this. Okay, yellow of lane 2 turns on and yellow of lane 3 turns on. Now what happens is that they should remain on for 3 seconds. That's good time as given here. Same time should be given here. For 3 seconds, yellow of lane 2 and 3 turns on, but at the same time, green of lane 2 turns off, becomes 0, and red of lane 3 also turns off. Red of lane 3 is at port C dot F0 equals to 1 as shown in the Proteus simulation. That I selected this pin, so this is the one I will use in the programming. That's why I told you they are very important. Red of lane 3. Now what happens here is that red of lane 3 is off. Make it 0. See, it's off. Red of lane 3 is off. Green of lane 2 is off now because it was on previously, and both yellow of lane 2 and 3 are on for 3 seconds. Then what will happen after 3 seconds? Since the one which is going from red to red must go to the red first, that is lane 2. So yellow of lane 2 will turn off, and at the same time red of lane 2, that is port B, pin number B3 equals to 1, like this. Red of lane 2 will turn on. Lane 2 turns on. See, yellow of lane 2 turns off, red turns on, and after 2000 milliseconds, 2 seconds, that is 2000 milliseconds, now the green of lane 3 must turn on as done previously in the previous case. Now we are dealing here with lane 2 and 3. That was lane 1 and 2. See, that is the second stage. Now green of the lane 3 is at port C dot F2, that is C2, port C dot F2 equals to 1 turns on. Green of lane 3 turns on, and the yellow of lane 3 have to turn off at the same time. You place it here, it turns off. Now the lane 3 should stay on for 30 seconds as done with the previous, like this. See, what is happening here is that red of lane 3 turns off, green of lane 2 also turns off, both yellows turn on. This is F1, sorry, I rechecked it. Yellow of lane 3 is at C dot F1 as shown in the Proteus, turns on, like this. Now what happens is that yellow of lane 2 turns off and red of lane 2 turns on. Now green of lane 3 must turn on. For that purpose yellow have to turn off. So yellow of port C, what is the yellow of lane 3 is C1, again the same, so turns off, and green of lane 3, that is C dot F2, turns on. Now we check the code till here. We build the code, check for errors. There are no errors. Go back to the Proteus simulation and check the code till here. Does it work as intended? Go to the schematics, click on run. Now again the code is running. Let's see what happens. Okay, green of lane 1 is on, red of lane 2 is on, lane 3 and 4 are also at red, that is the first stage. It is at 2 seconds, 3 seconds, it is going. Let it reach 30 seconds. Okay, it is at 28 seconds. Now change of state will occur. Yellow of both had turned on, that's perfect. Now this have to go red, lane 1 have to go red first. See, lane 1 has gone red and lane 2 have to go green after some delay. So lane 2 will go green. See, lane 2 is green and lane 1 is red now. Rest of the two lanes must be red at this stage. Okay, this is red, lane 3 is red, lane 4 is red. That's perfect. Now again, the new state will occur at after 1 minute, that is about 1.5 seconds. So we wait. Okay, it is above 1 minute. Now the state will change between lane 2 and lane 3. So we focus. See, red of lane 3 is on and green of lane 2 is on, but this have to change. Now both the yellows will turn on. Let's see. See, yellow of lane 2 is on and yellow of lane 3 is also on. See. Now lane 2 lane 2 will go red first, then lane 3 have to go green. Let's see. Lane 2 is yellow and lane 2 has gone red as programmed. Now lane 3 will go green. Let's see. See, it's green now. That's perfect. Now after 30 seconds, lane 4, it have to switch between lane 4. Now let's continue the programming. It is working excellently till now. Let's go back to our MikroC for PIC here. Now we have to switch between lane 3 and 4. Lane 3 and 4 like this. Now you copy this. This is a schematic now. You can make a schematic or a function out of it even if you want. But I'm going to leave it to you what you do further with this coding to make it easier. Okay. Now here red of lane 4 have to turn off. Now this will be our lane 4. Red of lane 4 must turn off. And what is the red of lane 4? That is D0. Port D dot F0 turns off. And green of lane 3, that is green of lane 3 C dot F2 have to turn off like this. Red of lane 4 turned off and green of, because green was on, it have to turn off. Now yellow of both the lane 3 and 4 must turn on. Yellow of 3 is C dot F1. This is the yellow of lane 3 and this will be our 4, and yellow of lane 4 is D dot F1 as shown in the Proteus simulation. This one. Yellow of lane 3 and 4 turned on. Now yellow of lane 3 and this will be 4. Now yellow of lane 4 now both the yellows are turned on. Now first of all, one that is going from green to red have to go to red. For that purpose we have to turn off yellow of lane 3, that is port C dot F1. This is yellow of lane 3, this have to turn on, that is single P, port C dot F1, yellow of lane 3 turned off, and red of lane 3 have to turn on, and red of lane 3 is at C dot F0, port C dot F0, red of lane 3 turned on. Now guys, green of lane 4 have to turn on. For that purpose, green of lane 4 is at D dot F2, and green of lane 4 is at D dot F2, it turned on, and yellow of lane 4 have to turn off, that is D dot F1 here. Now guys, let me recheck. First of all, red of lane 4 turned off, port D dot F0, that is what we selected, a digital input output pin for this purpose, turned off. Now the green of lane 3 which was on have to turn off at the same time, that is port C dot F2. Okay, green of lane 2 is off. Now both the yellows of lane 1, 3 and 4 should turn on. C1 and D1 have to turn on. Now the one going to the red must go to the red first before the green turns on. That is, after 3 seconds of both the yellows are turned on, it will take 2 seconds in which only red of lane 3 will be on while the yellow of lane 3 will be off. So red of lane 3 is at C dot F0. See, this is the mistake we were making. This is always good to recheck. C dot F0 is the red of lane 3 and yellow of lane 3 is at C dot F1. Sorry, it was not a mistake. Yellow of lane 3 turns off and red of lane 3 turns on. C.F1 turns on. Okay. Now after 2 seconds, lane 4 have to turn green on and turn yellow off. So D1 is the yellow of lane 4. This one it turns off, and green of the lane 4, that is D.F2, turns off. Now after this the code have to repeat. For that purpose what we do is that for a moment we have to turn this off. It turns off, so everything gets back to the initial stage. But before that, let's check what happens here. So let's see. Let's get back to the Proteus. This is our Proteus. Okay, I click on the schematic. Now again, let me rebuild the code. I had built it, but let's check for errors. There are no errors. That's great. Now run the simulation again. Now first of all, again it will start over again. Okay, green of lane 1 is on as expected, red of lane 2 is on, rest are off, red of lane 4 is on, red of lane 3 is also on as required. Okay, that's great. Now guys, we wait. It's just 3 seconds into the simulation. Let it go. See, after 30 seconds, yellow turned on, both the yellows turn on. See, it had turned red after both the yellows turned on, and this have to turn green. See, lane 2 is at green. Now let's get to the lane 3 and 4. After 30 seconds, lane 3 and 2 and 3 will switch. For that we have to wait. Okay, now both will turn on. It is 1 minute now. I had paused the video. This is our lane 2 and this is lane 3. See, both yellows turn on after exact 1.2 minute. See, now this will go to the red first and then lane 3 will go to the green. So we wait. This yellow have to go to the red. See, it's red, and now after 2 seconds this will go to the green. See, it's green now. Now after 30 seconds, this is green, it is open, only this is open while rest all are red. See, the rest all are red. 1, 2 and 4 are red, only 3 is green. Now there will be a switching between 3 and 4 after 30 seconds. So let's wait. So see, now it's the time for switching. Lane 3 and 4 both will go yellow. Okay, it is at DC, both are yellow. Lane 3 is yellow and 4 is yellow. See, this is 4 yellow, 3 and 4 both are yellow. Now lane 3 have to go red before lane 4 goes to green. Let's wait. On the hardware it will follow exactly the same timing. See, it had gone red. Now lane 4 have to go green after 2 seconds. On the hardware it will be exactly 2 seconds. This is delays. See, now it's completed. Now after 30 seconds it have to start over again. Now let's get back to programming. Our code is working exactly fine till here. Let me add another thing in the code before. Now see, after it has been executed till here, it is on for 30 seconds. After that we have to get back to the initial state. And what is our initial state before we go to the start? Let me show you. This is our initial state. Port B totally 0, port C and port E, they must be at 0. Because it was a one-time loop, this have to be again implemented here. Ports B 0, port C 0 and port D again get back to 0 like this. Now all 3 ports will be at 0 at the end of this code. So when it starts from the all over again, it is exactly at the same state as it was initially. Now guys, this is our complete code. Let me build it and show you on the Proteus how the complete code will work. Go back to the schematic capture, click on run. The new complete code has started. Let's see. Okay, initially lane 1 green is on, as you can see, only green is on. Lane 2 red is on, rest are off, you can see that. Lane 3 red is on, yellow is off, green is off. Lane 4 red is on, yellow is off, green is off. So this is exactly what we want. Only one should be on at a time, and that is lane 1. At this time it is a 4 second into the animation. You have to follow this time because this is the time of animation. In the real time hardware you have to follow the real clock. So it's going up. Okay guys, I am starting the simulation all over again because of it was working fine. Okay, the code has started. It's at 0 second. Let me show you the complete code now without pausing. This is lane 1, only green is on, all rest of the 2 are off. This is lane 2, red is on, rest of the 2 yellow and green are off. That is what we just want. And this is our lane 4, only red is on, rest of the 2 are off. And this is our lane 3, only red is on, yellow is off, green is off. That is what we exactly want. In the first stage, transition have to be made between lane 1 and lane 2. Only lane 2 will allow at this stage to move the car, and we are at 7 seconds into the animation. Let it get to 30 seconds. After 30 seconds, it will make the transition. Let's wait. See, it is giving exact result that we just needed. Only lane 1 is on. Green of the lane 1 is on, while the red of rest of the 3 lanes are on. At 22 seconds, 23. You have to follow this clock in the animation. In the real time on the hardware, you have to follow the hardware clock. Now it's nearly 30 seconds. Let's see. Transition will be made. See, yellow of both turned on. Lane 1 and lane 2 turn on as expected. See, yellow of lane 1 and lane 2 had turned on as expected. Now first lane 1 have to go red first before lane 2. This is our lane 1. Let's see. It have to go red. See, it is red. While the yellow of the lane 2 must be on at this stage. See, yellow of the lane 2 is still on for additional 2 seconds. Now it will go green. That will be exactly after 2 seconds on hardware. See, now lane 2 is at green, while rest of its red and yellow are off, and lane 1 must be red. See, lane 1 is red, yellow and green are off. Lane 3 is also at red, while its yellow and green are off. Lane 4 is also at red, while its yellow and green are off. In this way guys, only green is on and it will remain on for 30 seconds. So we have to reach 1 minute to see the transition. More than 1 minute to see the transition, because we had also spent 7 seconds on the yellow as well. 3 seconds when both yellows are on and 2 seconds when only this yellow is on. Now we wait. .55, it will reach its time. Okay, it's the time. See, lane 2 yellow is on and lane 3 yellow, both the yellows are on after exactly 30 seconds, because it is making a transition from lane 2 to lane 3. Now lane 2 have to go red first. See, it's red now, while lane 3 must be at yellow, and after 2 seconds it will go to green. It have to go to green after 2 seconds. See, it's green now. Now guys, this is lane 3 is on, lane 1 is at red, only red is on, yellow and green are off. Lane 2 is at red, yellow and green are on, off, only red is on, Now lane 4 only red is on, while rest of the two yellow and green are off. And for the green, you can see that only green is on, and for 30 seconds it should remain in this state. So let's see what time it is. It is 1.25. It had nearly reached that time. Let's see what happens. In 30 seconds it have to change the state. Yellow of both 3 and 4 will turn on. So there are difference of 14 seconds because we also add yellow, 7 seconds for the yellow. So it is after 37 seconds. And on the hardware it will be exactly 37 seconds. Because here we have to follow this clock, not the hardware clock. So it is 1.37. At 1.44 we also have to calculate. See, it has now transitioned. Now both the lane 3 and 4 are at yellow. See, this is yellow and lane 3 is yellow. Now lane 3 have to turn red first as programmed. See, lane 3 is now red while lane 4 is still at yellow. Now lane 4 will go green after 2 seconds on the hardware real time. See, it is green now. Now lane 4 is green while its red and yellow are off. Lane 3 is red on, yellow green off. Lane 2 only red on, yellow green off. And lane 1 only red on, yellow green off. This is what we exactly want. Now for 30 seconds lane 4 will remain on, and after that there will be a transition made between lane 4 and lane 1 all over again. So we wait and see what happens. This is lane 3, this is lane 4. So we have to wait for 30 seconds. Nearly at 144 it made the transition. So it is now like 10 to 12 seconds of this animation, not the real time. We are using the time of this animation. Now we have to wait. Yellow of lane 4 and let's wait for 30 seconds. See, it has started all over again. Lane 4 turned red and lane 1 turned green. Now it will go all over again. See, lane 1 is green, lane 3 is red, lane 4 is red, lane 2 is red. I stop the simulation, no errors. So guys, did you saw that at the transition from lane 4 to lane 1, when it have to go all over again, it went red and this went green because we didn't make a transition code for this. So we make a code for lane 4 to 1. So it goes back smoothly. So we write here, you have to add here lane 4 to lane 1, lane 1. Now what we do here is that first of all we need to turn the yellow of lane 4 and 1 on. Yellow of lane 4 is port D dot F1, okay, equals to 1. Yellow of lane D, yellow of lane 4 is on, and yellow of lane 1 will also turn on. Port D dot B dot F1 is equal to 1. That is the yellow of lane 1. Yellow of lane 1. See, yellow of lane 4 and yellow of lane 1 both are on. Now guys, this is on for how much second? That is the 3 seconds that we use every time. Like this, it is on. And now after that, what happen is that at the same stage, green of lane 4 have to turn off at the same time. So green of lane 4 turns off, yellow and only yellow of both the ports are on for 3 seconds. Now since it is going to red, now red of lane 4 have to turn on. Port D dot F0 equals to 1 and yellow of lane 4 have to turn off. This have to turn off. That is, red of lane 4 is on and yellow of lane 4 is off, and that will remain in effect for 2 seconds. For 2 seconds this will remain in effect. Now the next thing is our initial stage. Now we are going back to our initial state, that is the port 1. It will turn on the LED of lane 1, that is this green. So green of 1 will turn on while yellow of 1 will turn off. This is the yellow, so you have to do this. Yellow turns off, then it will follow rest of the code as initially planned. So guys, in this way we interconnect the starting and ending of the forever loop, so it will remain in ribbon. We build the code and let's go back to the Proteus and see what happens in the end again. So our code has begun. It is a long code, so I will skip you to the last part. It is just at 1 second. So guys, I had skipped it to 1.58. Green is on and now it has to make a transition from lane 4 to lane 1. Now see, the code I added will make it smooth again. Okay, it is running. Now yellow of both lane 4 and 1 will turn on. After that, lane 4 will go red and lane 1 will go green. Let's see, yellow have to turn on. Unlike the previous time, it went straight from green to red and that went to green. Let's see. Okay, this is the clock we are following here in the animation. See, it is yellow and lane 1 is also at yellow. See, lane 4 is yellow and lane 1 is yellow. Now lane 1 is green, but red is also on, so we have to deal with the programming. Yellow is also on, red is also on. There is a problem, and let me show you what is the problem. So I stop the simulation, I go back, I remove 3 lines from here. That was the initial state. We have to give it the initial state here. We forgot to give the initial state. This is our initial state. I removed these lines and didn't place them back. You copy them, paste them here after that. So your program must get into the initial state before restarting. So everything should be in the initial state. Port B, port C and port D have to be in the initial state like this. Now we can okay guys, there you can see I turned on the yellow. Yellow must turn off after 2 seconds. See, yellow of port B dot F1 is on here, but yellow of port B dot F1 okay guys, you can see here the yellow of lane 1 is on and it should remain on for 2 seconds. After that, yellow have to turn off like this, and then it will follow the code from the start after going to the initial values. Now I build this code. and I go back and initialize it to the simulation. I click on go. The simulation is running. I will lead you to the end. So guys, it's at 2.10 and I had to go skip the video so I can show you where we were lagging. So lane 4 is on while rest are off. Lane 4 have to transition into lane 1 now. Let's see what happens. This time we made changes in the code. So this is the time it will make the transition. Remember, in the Proteus simulation you have to follow this clock, not the original clock. Original real-time clock works only in the real hardware. Now see, it's yellow. Lane 1 is also at yellow. See, but the red is on. There is still a malfunction. Let's see. Rest of it works fine. It's yellow. And now see what happens. It will go red. Lane 4 is red. Now lane 1 have to go green. After 2 seconds of this animation, see, it's green. See, our code is working fine. Only there is a little malfunction that it is red. So we remove it as well. So let's back to the Proteus simulation. In the Proteus simulation, let me show you where we are lagging. There we are lagging. See, when we turned the yellow on for the lane 1 here, we didn't turn the red off of the lane 1. At this time, red of the lane 1 is also off because it is in the other loop. It is currently on because these are on. So red is also on. So we have to turn the red off as well here. We forgot to turn off the red here. So you turn off the red of lane 1 as well. Port B.F0 equals to 0. That is the lane 1 as shown in the Proteus. I had selected this digital input output pin. This will turn on the red of lane 1. Now red of lane 1 will be turned off as soon as the yellow of red lane 1 turns on. I built this code and let's get back to the Proteus and repeat the code and see this malfunction is cleared or not. Rest is working fine. So I run the simulation. So I will get you to the last where we are lagging. Okay, it's at 1.53. Green is on of the lane 4. And now it will have to make transition to lane 1. Now we see the malfunction it was making, that the lane 1 red LED was on is removed or not. Guys, this is a detailed video. I make such videos to show you how you do the debugging and programming of your projects and how you use the Proteus software. You only don't learn how to make the traffic controller, you will also learn how to use the debugging softwares to debug your code before implementing of the hardware. That is the true requirement of Proteus, that it allows you to debug here. So let's see. This is green. What is the time of the animation? It has reached 2. At 2.7 or 8, it will make the transition. Yellow of lane 4 and lane 1 must turn on as we saw in the presentation, and then this will go red and lane 1 have to go green, and after 30 seconds again lane 2 and then 3, 4, it will repeat all over again. So let's see what is the animation time. 2.910. It is the time. Lane 4 is green, rest of all the lanes are at red. Now this will go yellow and lane 1 will go yellow as well. See, it's yellow and lane 1 is yellow. And see, that malfunction has been cleared because this was also red previously. So I removed the malfunction. Now they both are at yellow. This is working perfectly as required. Now this one have to go red. Let's see. It is red. Excellent. Now this one have to go green after 2 seconds of this animation, and in real time it will be the 2 seconds of the real time clock. It will go green. Now it will run all over again. It is green. After 30 seconds, it will make a transition to lane 2, 3, 4. So guys, this is it. This is the project. And this is a very lengthy and a good project. You can make it for your university stuffs as well, and it is also a 100% real-time working project. You can also make it for the real-time application of a traffic controller. This has no bugs, nothing. I will share the code as shown in the presentation and in the programming in the description of this video. If you have any questions or comments, any questions or queries, you can ask in the comment section below. I will respond to all the comments, and I always respond to the comments. So thank you very much for your time. Let me show you the transition from lane 1 to lane 2, that it is running all over again. After 30 seconds, see, it will keep on going now. It's a loop. The loop has been completed. After 30 seconds, it will make transition. Lane 1 and 2 both will go yellow. Let's see, lane 1 is at green, lane 2 is red. The rest of the two lanes, lane 4 and lane 3, they are also red. That is what they must be. And now the lane 1 will turn yellow for 3 seconds of this animation, not of the real-time clock. Let's see. It will turn yellow, lane 2 will turn yellow. I'm just showing this to you that you know that it has correctly, we have connected the forever loop from end to top. That transitioning from lane 4 to lane 1, that is a real challenge. Now let's see. I don't know at what time it ended. You have to add the 7s into 4, that is 28 seconds. Now it's yellow and lane 2 is also yellow. See, it has correctly transitioned. Now it will keep on repeating the loop, lane 1 2 3 4, then 1 2 3 4, 1 2 3 4 forever. So guys, thank you very much for your time. I will share the programming in the description of this video, and you can take this Proteus file from me. You can email me. I will share the email as well in the description, or I upload it into my Google Drive and I share the Google Drive link to you. I will do the both. I will also give you the email of this Proteus file, and I will also share it on my Google Drive, and I will share the Google Drive link in the description below. So guys, thank you very much for your time and have a nice day. Bye.